All right, in this video we want to begin talking about polar coordinates. So polar coordinates are used in navigation. We can use them to make some, I always say derivatives and integrals easier, but mainly integrals. They make some shapes that we didn't know how to deal with before. They make those shapes ones that we can find slopes of or areas of. It opens up some new options to us and some new ways of finding doing some calculus on, as I said, shapes and graphs we didn't know about before. And it does make the prettiest graphs. Coordinates are given to you in terms of an r and a theta. R is a length, and theta is the angle away from the polar axis, which we would normally consider 0 radians or 0 degrees. So in this video, we want to talk about how we could graph some points and how multiple points or coordinates all go to the same spot on the graph. I hope it makes sense why this would be used in navigation, because X and Y Cartesian system, we don't usually move. If we're given the choice, we'd rather move along a hypotenuse. We'd rather move straight to a destination rather than saying, well, we have to walk 5 steps forward and 3 steps to the side. We would rather just walk at the correct angle to walk straight to that point. And that's what polar coordinates get to. So let's talk about graphing. The point, 2 pi over 4. So what I have here is a polar graph. The angles, this is the polar axis. This would be considered 0. Of course, this would be pi over 2. This would be pi. And this would be 3 pi over 2. So you've got pi over 4, pi over 3, pi over 6, and so on. Okay. The blue rings represent r. So this is like an r of 1 is this circle here. An r of 2 is this circle here. So when we say 2 pi over 4, we're really getting at a point that's on the, and I always start with the angle. We go to pi over 4, so this red line here, and then we count out 2 units. So it is right there. Okay. Now, so it's right there. One of the kind of interesting things about polar coordinates is that other points or other coordinates can map to the same point. For instance, instead of pi over 4, if I said 9 pi over 4, that would go to the same point, because of course 9 pi over 4, well, you go around, it's pi over 4, pi over 2, and so on. You go all the way around. This is 8 pi over 4, or 2 pi. So you go to 9 pi over 4 and out 2, you're at the same spot. You could also go backwards. You could use the angles going backwards. You could say, well, I still want to go out 2 units, but I want to go negative 7 pi over 4. And a negative angle means you're, instead of moving counterclockwise, you're moving clockwise. You're going this way. So like this is negative pi over 4, negative pi over 2, and so on all the way around to negative 7 pi over 4, now 2. Another way you could do this is with a negative radius, like that. And how you would do that is you would want to come around to this angle. So you're saying, well, I want to go, this would be pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. It would be 5 pi over 4. Like that. So you would come to that 5 pi over 4, but then the radius is negative 2, so you would count back 2 along that angle. So all of those coordinates all map to that red spot. Okay. Let's do one more. This one is pi over 4 and negative 2. So again, pi over 4 is right here. Negative 2 maps back this way, so it would be right here. And again, we could do the same thing, finding other coordinates that go to that point. We could say, well, instead of negative 2, what if I said it was positive 2 and just 5 pi over 4? Right? So that way you go to 5 pi over 4, you'd come around here and just go out 2, go to the same spot. Another way to do it would say, well, I'm going to keep my negative 2, but I want to go all the way around the circle again and a little further. So 9 pi over 4. That would map to the same spot because you would come all the way around back to 9 pi over 4 and then back 2. Another way would be to go to the positive 2 and say, well, what about a negative angle, like negative 3 pi over 4? And that would do it too. So there are an infinite number of coordinates all map to the same spot. Let's do a little practice. So we're going to plot these points. 5 pi over 3. I would always start with the angle, 5 pi over 3. So, pi over 3 is up here, 2 pi over 3 is there. So on 5 pi over 3 is just short of 2 pi. It's actually going to be the pi over 3 back here. We go 3 units out. I'm going to do this one in black, put a little black thing there. There it is. Okay. Next, we've got negative pi over 4 and 2. So negative pi over 4 is back here, out 2 units. Let me do this one in red. It will be right there. Next, we've got 3, 0. Well, this is 0. That's just right along the polar axis. Out 3 units. Here. And the pi over 4, negative 2 I did on the previous slide. That gets us a little practice. Let's look at one more thing we can do. So we're going to graph 3 and pi over 6. All right. So I start with pi over 6. That is right here in this line. And I'm going to go 3 units out. 1, 2, 3, right in there. Okay. Now, I said find another coordinate that has the same point, and then I gave some kind of additional instructions here. I said the radius is still positive, so obviously it's still 3. But the angle isn't pi over 6. It's got to be between 2 pi and 4 pi. Well, that just means we go all the way around the circle. So 2 pi and another pi over 6. Well, 2 pi is the same as 12 pi over 6. So another pi over 6 would be 13 pi over 6. Okay. The next line here, I said, nope, the radius has to be negative. Okay, so I want to use a negative 3. So what I've got to be dealing with then is some angle over here that when I go back 3 gets me right onto there. Well, it's got to be a pi over 6. Of course, this is 6 pi over 6 right here, so it must be 7 pi over 6. It must be 1 pi over 6 past that. And finally, I'm back to a positive r, but I want a negative angle. Okay, remember, going all the way back around, all the way would be a negative 12 pi over 6, because that's the same as negative 2 pi. This is 1 pi over 6 less than that, so it's negative 11 pi over 6. Let me clean that up a little bit.